Hello class and welcome to lesson 7.2 geometric series. Sorry, geometric sequences, my fault. So what we're going to remember guys is anytime we have sequences that has commas. As I slipped up and said series, we're going to deal with series in the next couple lessons. So I apologize for saying that early, but you're going to hear series soon enough. But right now for today, we're going to be dealing with geometric sequences, and sequences have commas. And now that you're curious, the series, guys, will have plus signs in between the numbers as opposed to commas, okay? All right. So just recall here, guys, from last lesson, arithmetic sequence has a common difference. So basically, you would take T2 and subtract T1, or T4, subtract T3, okay? That means difference, which is D, okay? Now we're going to learn today a different type of sequence, and this is called a geometric sequence, and it has a common ratio between the consecutive numbers. Okay, so you'll notice that the numbers are either going to be rapidly increasing or rapidly decreasing. Okay, let's think just a second, for example, A. What is happening in this pattern? I could look to 2 to 4 and say, hey, it's adding 2. But when I go 4 to 8, is it adding 2 again? No, there's something different happening. So instead of adding or subtracting, we have what's called a common multiplier. Okay? And the multiplier is the little r, which is ratio. So instead of writing plus 2, I'm going to go times 2. Times 2, times 2. Okay, and that when you're timesing to get from one term to another, ladies and gentlemen, that gives you an R value. So R equals 2 for that. And the same terminology we're also going to use for the first term. That's going to tell us that A equals 2. Second example, ladies and gentlemen, be careful here when you've got one term positive, next term negative, one term positive, next term negative, etc. You've got to watch your signs. So what we know is if it's changing positive to negative, we know it's got to at least be negative. And what's happening, we're going to be timesing each by negative 4. So times by negative 4, times by negative 4, and times by negative 4. Okay, so in this case, R equals negative 4. And A, looking at our first term, A equals negative 1. If you're having trouble finding this out, folks, instead of subtracting for a common difference, for a common ratio, you're going to divide. So it's T4 divided by T3. Okay, so we follow that through, guys. If you say take T4, which is 64, and you divide it by T3, which is negative 16, positive divided by a negative is a negative, and 16 goes to 64 4 times, so that will give you your R value. Okay? Awesome. So again, you just have to recognize the patterning. Notice, again, there's commas, so that sequence, that's going to change next day. We're going to see plus signs. But you also have to be able to differentiate when it's arithmetic or geometric. All right. So taking a look, for example, 1, it says state the recursive formula for the sequence. Okay. Looking at this following sequence, start with the first letter, start with the first term. That tells us A equals 3. And then we've got to compare what's happening each time. Okay, I'm just going to move A equals 3 over more so I can do my patterning. So I will say A equals 3. But what's happening each time, guys? Hopefully you recognize that you're timesing by 3. Okay, so that tells us that R equals 3. Okay, so to do our recursive formula, you're going to say t to the n equals, now it's R because you're timesing it, not subtracting or adding it, to the n minus 1. Okay, and if we simplify it into our equation here, it's going to be t at n equals 3 times t to the n minus 1. All right, so that is the recursive formula for this. Just remember, recursive says, hey, how do I get to the next term from my previous term? So the previous term represents this, tn minus 1, and what's happening in this case, we're multiplying, so that's why it's timesing. All right, let's take a look to develop how we develop the general term for this. every geometric sequence has the following pattern. Well, if we take a look at, sorry, as I drop my marker, if we take a look at n and compare it, sorry, straighter line might help, so they can fit it in here. Okay, if I take n and compare it, ladies and gentlemen, to t at n, okay, remember term 1 is letter A. Okay, term 2, to get term 2, I've got to take A and times it by my R, guys, which is my recursive, so it's going to be AR, and I'm going to say to the exponent 1. To get to my third term, I've got to take my second term and times it by R. So it's going to be AR, and it's going to be R times R, which is R squared. Okay, take a look at my fourth term. I take a look at the third term and times it by R, so it's going to be AR to the third. So what I'm developing here is our pattern that we're going to write out in just a second. So whatever term number you're looking for, it's A times R to the n minus 1. Okay, and we also have to remember, guys, that because this is discrete, it's a discrete function, that it's going to be n belongs to a set of natural numbers. Okay, all right, so let's write this formula down, ladies and gentlemen. Okay, how do you recognize the difference between these? This is an R as opposed to a D from last class. Okay, A is still the same. A is the first term number. R is our new one, and A and N is our term number, depending on what we want to do. Okay, and as I've already addressed above there, our recursive formula is T at N, where you take whatever term you have, times it by R to get the next term. And just remember, guys, that the first term equals A. All right. So I want you to think of the graph that we did last day of an arithmetic sequence. Hopefully you remember that, ladies and gentlemen, we had what's called a constant slope. Even though we didn't join the lines, we still had a constant slope, which means, hey, in our graph we were going to have what's called same first differences. Sorry, on our table. So same first differences. Okay, and that led to a linear graph. Just look back at last day's lesson if you're not sure. Now today, ladies and gentlemen, we're looking at a geometric sequence. Okay, and a geometric sequence means that we have what's called a growing rate. Okay, if you remember back to one of our previous units, we talked about a y ratio. Do you guys remember when we talked about the y ratio? The y ratio is used in the exponential unit, right? Okay, so just remember that when you are dealing with a geometric sequence, ladies and gentlemen, that's going to lead or graph an exponential graph. Okay, let's do an example here to prove it. Okay, so taking a look at this graph and say here is our sequence here, guys. We're going to start with 1 and 3, okay, 2 and 9, okay, 3 and 27, and 4 and 81. Okay, and again, guys, I'm going to draw a dotted line through the trend of my data because it is discrete. Okay, just remember, discrete function, therefore no solid line. Okay, now it says to express this in function notation. Okay, so the first thing we have to realize is what's our A? So A equals 3, and what's our R? Okay, from above I think we did this same example, R equals 3. So to do function notation, you're going to go f at n equals A, which is 3, times R, which is 3 to the n minus 1. Okay, so just using the above formula, Okay, and I just put function notation and made it f at n. So just remember, the first letter is a, so that's what that first 3 represents, and the second 3 represents your r value. Okay, guys? In that equation. All right, let's take a look at another example on the other page. Example 2. State the general term, the recursive formula, and function notation for the following sequence. Okay, so we're given 3 values, 9, 36, and 144. What information do we know already? Well, hopefully you realize that a equals 9. And hey, what's happening each time, guys? Okay, again, if you're not sure, take 144, divide 36. Okay, plug it in your calculator and you should get the value of 4. So that then tells us that r equals 4, because each time we're timesing or multiplying. It gives that ratio. Okay? All right, so now that we know that information, let's start answering some of these questions. So first part, the general term. So what do we know the formula for the general term is? T at n equals a times r to the n minus 1. Sub in the information we know. So T at n equals 9 times 4 to the n minus 1. Don't forget to state that n belongs to a set of natural numbers. Okay, because it's a restriction. Okay? Any questions on that? Okay. Second one. Okay, state the recursive formula. Okay, so remember the recursive formula, it takes the term before, which is t to the n minus 1, and you times it by the ratio. So our ratio in this case is 4 times t to the n minus 1. And don't forget to state that n belongs to a set of real numbers. And the last one, ladies and gentlemen, is function notation, which if you're planning to take grade 12 functions, you got to make sure you know how to do this. You just replace it, so it's going to be f at n equals 9 times 4 to the n minus 1. And don't forget that n belongs to a set of natural numbers. All right. Okay. So, example 3. The fourth term of a geometric sequence is 243, and the seventh term is 2,187. Find the 15th term. And it says it's tricky. It's tricky because we're not given the start of a sequence, so we don't know what A is, right? Okay, so what's not given? So it's tricky because we have no A, and what else? If we don't have the sequence, we can't figure out the R. So we don't have no A or R given. So we've got to figure out some other strategies. Okay? And we're going to just use the wording of this. The fourth term is 243. So T at 4 equals 243. Everybody with me? Hopefully. Let's try the next one. I'll do a different color over here. The seventh term is 2,187. What does that mean? T at 7 equals 2,187. Hopefully everybody is okay with that. All right. Now that we know that, we have to remember, hey, how else can we express these term numbers? If I know, if this is term 4, I know that that's going to be, if you back it up 1, it's going to be the ratio of the third times A, which equals t to the fourth. So that equals 243. Okay. Likewise, t at the 7th equals r to the 6th times A. Just go back to your recursive formula for the general term. Okay. And what do we know about that, folks? That's 2,187. If you're not sure how I got this, please come and see me, guys, okay? All right, how I transfer those. All right. Once I have that, ladies and gentlemen, notice that I now have some common variables. So I could actually, notice I've got A in both equations. I can rearrange for A. So I'm going to say A equals 243 over r cubed. Okay, in the first section. And the second one here, I've got A equals 2,187 divided by r to the 6th. If I was thinking back to mathematics and I let this be equation 1 and equation 2, I could use substitution to solve, right? Because A equals A, so we're going to let equation 1 equal equation 2. Why is that? Because A has to equal A, right? Okay, so I'm going to write 243 over r cubed equals 2,187 over r to the power of 6. Okay, we can cross multiply. Okay, so if we cross multiply here, ladies and gentlemen, we're going to have 243 r to the 6th equals 2,187 r cubed. So far, so good? Okay, so let's try to get r by itself. I'm going to take the smaller one here, so I'm going to divide through. Whatever I do to one side to keep it balanced, I have to do the same to the other. Why am I doing that? Because I'm canceling this out. Okay, so what am I left with? Well, I can simplify this using my exponent laws. I know I've got 243, but that's going to be r to what power? R to the power of 3, because division law tells you subtract those exponents, equals 2,187. We're getting closer here, guys. How do we find r? Well, first of all, let's deal with how do we get r cubed by itself. Currently, it's multiplied by 243, so you do the opposite, which is divide. Okay. I'm just going to move it up here so I don't run out of too much room. So what am I left with here, guys? I have r cubed equals 9. Okay. Another way to write that, ladies and gentlemen, is r equals the third root of 9, because we've done our radicals already. So that's another way to express it. Let's leave it like that. Okay? Plug it in your calculator, you're not going to get a nice value, so let's leave it as an exact value. That's why we're using radical or rational expressions here. So what we're going to do now is we're going to sub r equals the third root of 9 into an equation. So let's take the first one. ar cubed equals 243. So we're going to have a, and subbing r in, be careful here, guys. I'm subbing r in, which is, I'll do that in different colors so you see. I'll do that in the red. So when I sub r in, it's the third root of 9. Okay, but then don't forget, this expression tells me I've got to cube it, so that's the exact same transfer there. And what do you guys remember when you're cubing and taking the cubic root? These two cancel out. Okay. Or just like when you're squaring and square rooting, they're opposite operations. So what are we left with here, guys? 9a equals 243. Okay. Divide both sides by 9. So a equals 27. Now that we've got a, we know r, we can sub values in to find the 15th term. So now, so I can save some room here, now we can sub in. Yeah, I thought I was running out of room here. So t at 15 equals a, which is 27, times r to the n minus 1. Okay, sub that in. So we've got 27 times the third root of 9. And n is 15, so it's 15 subtract 1. So you get 27 times the third root of 9, all raised to the exponent 14. That's where you have to plug that in your calculator, ladies and gentlemen. So it's 27 times third root, y to the x 14th. And hopefully you get something like 766,470.6 rounded. Okay? Does that make sense, ladies and gentlemen? Well, let's just take a look here. We know that our ratio is increasing, right? Because we know from the 4th term we're at 243. The 7th term we're already at 2,000. So does it make sense to have a big number? Absolutely. Okay? All right. Okay. So ladies and gentlemen, that was a tricky one. So give that a try, and here's your homework, ladies and gentlemen, page 430, numbers 5 to 7. Just do ACE, every other one for those, so every odd example. For number 6, I'd like you to add function notation. The textbook doesn't do a good job at that, and I think that's where you can be better prepared for functions in grade 12 if you keep adding that in. And 11, 12, and 14. Have a great day, guys, and come and see me if you need some help. Ciao.